Wildfire. What do you think of when wildfire is mentioned? A destructive force of nature, perhaps? Well, when it comes to wildfire, destruction is not the full story. In most places, the historic pattern of wildfire on the landscape has been disrupted. These patterns that include fire frequency, seasonality, intensity, severity, type, extent, and spatial pattern are called the fire regime. In order to bring an ecosystem back into a healthy balance of fire, it is critical to understand the characteristics that define its fire regime. This video is part of a series that delves into the intricate world of fire regimes in the southwestern United States. These fire regimes tell the narrative of how landscapes have co-evolved with fire over time, providing insight into the important ecological role that wildfire plays in shaping the diverse ecosystems of the Southwest. In an arid region like the southwestern United States, mixed-conifer forests are ecosystems that act as a mountain oasis for humans, wildlife, and plants. One of the most unique features of the southwestern U.S. is the diversity of landscapes that range from desert to alpine. Many of these ecosystems are arid, semi-arid, or water-limited, where patterns of vegetation are dictated by availability of moisture. Moisture availability can shift across time, seasons, soil types, elevation, and solar aspect, to name a few. Mixed conifer forests occur across the southwestern United States and are typically found in the mountains at elevations between 6,000 to 9,000 feet, sandwiched between pure ponderosa pine forests at lower elevations and spruce fir forests that occur at higher elevations. Mixed conifer forests are a gradient between these two forest types, meaning that at the lower end of the elevational gradient, we find what are called dry mixed conifer forests that include ponderosa, Douglas-fir, white pine, aspen, and white fir. On more mesic or high moisture sites, we find wet mixed conifer forests that include some of the same species, except for no ponderosa pine and more Engelmann spruce. This elevational gradient defines the amount of moisture and determines the composition of tree species in mixed conifer forests. It also plays an important role in the fire regime of these areas. In addition to the diversity of plant and animal species that inhabit these forests, mixed conifer forests are also unique because they evolved under a combination of fire regimes. Historically, fire was common and naturally reoccurring in most southwestern mixed conifer forests. We know about fire regimes by studying tree rings and fire scars on trees. When fires occur, the trees that are burned but not killed record a memory of fire that can be seen in their rings. Fire scars, also called cat faces, are found on the lower trunk, right against the surface of the ground. Not all trees in a burned area have these scars, and in mixed conifer forests, some species have thick bark that prevents scarring. However, trees that have more fuel resting against them, such as a downed tree leaning against their trunk, or have had their bark damaged by animals, people, or insects, will be scarred by wildfire. Dendrochronologists, the scientists who study tree rings, can use fire scars to determine the year and even the timing of these fires thousands of years into the past. A fire regime is characterized by temporal attributes including frequency and seasonality, the characteristics of magnitude which describe the intensity, severity, and fire type, and the spatial characteristics which involve the size and geometric pattern of fire. These attributes have a strong influence on vegetation recovery, plant succession, and forest and ecosystem structure. Similarly, because fire regimes were historically stable over time, plants adapted to the region's fire regime by developing certain reproductive and growth characteristics such as thick bark, the ability to resprout from roots, or winged seeds. Mixed conifer forests exist with a variety of conditions that range from dry to wet, and the moisture levels greatly affect the fire regime. In dry mixed conifer forests that include ponderosa pine, fire prior to Euro-American colonization was relatively frequent. On average, these drier forests would experience fire every 5 to 15 years. The arrival of European settlers in the 1880s altered fire regimes in a few ways, including by suppressing natural fire events and changing vegetation structure and ecosystem function with the logging and grazing practices used at the time. In addition, the eradication and displacement of native peoples put an end to indigenous burning practices and altered relationships between people and the forest on a landscape scale. These collective impacts resulted in a decrease in the frequency of fire. Fire was historically less frequent in the wettest, mesic mixed-conifer forests containing spruce and fir species. The timing between fires in these high-elevation forests range from multiple decades to over a century. Historically, fires in both wet and dry mixed-conifer forests burned in the summer with some variation across the region due to local factors. The timing of the start of the Southwest's summer monsoon rains and associated lightning ignitions, which often progress from the southeast corner of New Mexico to the northwest corner of Arizona, was likely one factor that influenced fire season. Fires were historically ignited by both lightning and people, including through indigenous burning. While the study of dendrochronology can detect fire frequency, it does not allow us to know the cause of ignition. We can learn about how fire started through oral history, as well as by studying modern fire patterns, and therefore know that both types of ignition sources occurred and varied in time and place. Mixed conifer forests burn across a range of fire intensities, severities, and types. The amount of forest burned in high-severity fire and the amount of surface and crown fire varied between dry and wet mixed conifer. Frequent fires in drier mixed conifer forests reduced the buildup of fuels, which resulted in the dominance of relatively low-intensity surface fires. Due to the moist nature of wet mixed conifer forests, severe drought events were necessary to start and carry fire. Fires in these forests often burned with higher intensity and caused larger patches of stand-replacing crown fire than in dry mixed conifer forests. We know that wet mixed conifer forests historically experienced high intensity and high severity wildfire by using dendrochronology, analyzing tree ring structure, and looking at the adaptations of tree species, such as aspen, fir, and spruce, that live in these areas. These species regenerate quickly post high severity fire compared to drier mixed conifer species, such as ponderosa pine. Fire frequency, intensity, severity, type, and fire size and spatial pattern in wet and dry mixed conifer forests, fire extent and pattern also varied. Historical fire ranged in size, but large fires, thousands to potentially hundreds of thousands of acres, likely occurred. Using dendrochronology, scientists know that fires burn synchronously across sites separated by kilometers with mountain ranges as well as at sites in different mountain ranges. This synchrony allows scientists to determine that expansive fires occurred historically, most often during drought years. Mixed conifer forests historically burned in a mosaic. They experienced patches of high, moderate, and low severity fire during the same fire event. In drier mixed conifer forests, low severity fire was historically more frequent, and high severity patches were likely small. During years of severe drought, fires could burn into higher elevations and into wet mixed conifer forests, resulting in patches of moderate to high severity fire that would kill mature trees. In these wetter forests, larger patches of high severity fire were common. Given the complexity and diversity of these ecosystems, understanding and managing the fire regime is crucial for maintaining the health and resilience of mixed conifer forests in the face of climate change. Mixed conifer forests provide essential services to the Southwest, including water, biodiversity, and tourism. This forest type is limited in the Southwest, and land managers recognize that it is vital to protect. Increasing droughts in the Southwest since the 2000s have resulted in fires that have impacted mixed conifer forests in Arizona and New Mexico at higher rates compared to other forest types in the region, making the protection of these areas a high priority. The suppression of wildfire has dramatically changed forests in the Southwest. Forests that historically burned frequently have not seen fire for up to 140 years. Without fire to clear understory and kill smaller diameter trees, more trees have established and filled understory gaps, creating vertical, continuous fuels. Dry mixed conifer forests previously dominated by ponderosa pine are experiencing infill from wetter, less fire-tolerant mixed conifer tree species. This has led to an overcrowding of forests as tree density increases. Additionally, less fire-tolerant species also create fuel ladders with their branches, leading to an increase in the horizontal continuity of canopy fuels across landscapes. Land managers recognize that there is a fire deficit, and that fuel reduction is needed in mixed conifer forests. Mechanical thinning, prescribed fire, and managed wildfire are tools that are becoming more commonly implemented for restoration. Forests benefit from a diversity of plants and animals, and healthy forests provide essential ecosystem services, including outdoor recreation and carbon storage. In the Southwest, mixed conifer forests surround major water sources that are indispensable in an otherwise arid region. As we experience increasingly hotter temperatures and drier conditions, creative forest restoration and resilient strategies can help us maintain healthy ecosystems that will in turn protect our communities from the effects of high severity wildfire.